Hello guys, welcome to lesson 4 physics for grade 12 learners. And also just before I start with the lesson, thank you for the support, thank you for watching our videos, thank you for liking our videos. Also do join us in the next lessons. And in this lesson we'll be covering vertical projectile for grade 12 learners. And I'll be doing some examples that I've come up with. Well, let's get right onto it. So now the first example or the first question says, a stone is dropped off a bridge and strikes the water below the bridge after 6 seconds. And now they say ignore air resistance. Oh, guys, before I continue, these questions are going to pop up on your screen there. You can just pause the video, write the questions down, and then I'll be solving them for you here. So now this question, it says, calculate the vertical distance that the stone fell. So we need to calculate the distance that this stone is going to fall from the bridge to the water below the bridge. So now from the previous lesson, we covered some formulas that are very important when we're dealing with motion or vertical projectile motion. Well, you need to look, before you can tackle each and every question, you need to look at what's given in the question. The given information, you need to write down what's given there. So let's just write it down for you. So we're dealing with question 1. So from that question, we're given the time that the stone takes from the bridge to the water below the bridge, to hit the water below the bridge. So now that's time, or the change in time, we're given as 6 seconds. And now also remember that when we're dealing with vertical projectile, the acceleration that we'll be considering is the acceleration due to gravity, or the gravitational acceleration, which is given as g. That's 9.8 meters per second. And also you need to remember that in physics, it's very important to choose your directions when you're dealing with vector quantities. So now in this case, because we're dealing with vertical motion, so we need to take our directions as upwards and downwards. So we need to choose which of those directions is going to be positive and which one is going to be negative. So now for this question, let's take downward motion to be positive. So anything going or moving in a downward direction, it's going to be positive as a vector quantity. And anything moving upwards will be negative. So we're taking downwards as positive. So it's very important to avoid making mistakes when solving such questions or such problems. Okay, so now since we have our given information, we've got acceleration and also the change in time. And remember, this acceleration due to gravity is always downwards. It's always going in the downwards direction. So since we're saying downwards is positive, that means this acceleration is going to be positive as well. So now let's go on to choose the right or the suitable equation for this question. So now from the formulas from our previous lesson, we can see that when we have the change in time and acceleration, we need to use an equation that says change in y equals to v, initial velocity, multiplied by time, plus half, multiplied by acceleration, multiplied by the change in time squared. Because now we've got the initial velocity. That's when the object or the stone starts moving. So it's going to start at a velocity of 0 meters per second. I need to write that down here for you so that you guys can note that down. So now the initial velocity is 0 meters per second. So you need to remember that. That's why we're choosing this equation here. Because we've got all these other variables. We've got the time, we've got acceleration. So we're using this formula here. So from there, because we need the h, or the change in height, you just need to plug in and play. Let's plug in our given variables. So now initial velocity is 0 meters per second. Just put it in there. And then we're also given the seconds or the time that it takes to hit the water below the bridge. That's 6 seconds. Plus half, well, the acceleration is g, which is the acceleration due to gravity. That's 9.8 meters per second squared. Multiplied by the change in time, which is given as 6 seconds squared. So now from there, you just need to use a calculator and calculate this change in height. So you know that 0 multiplied by 6, that's 0. So we just need to work with the remainder of that equation, which is half multiplied by 9.8 multiplied by 6 squared. So now we're going to get 176.4 meters. You understand? So now this means that this, or the water below the bridge, is 176 meters below that particular bridge. And then now let me just write it down here in words. Vertical distance is 176.4 meters below the bridge. So now let's move on. This is 1.1. You need to remember it's 1.1. Let's move on to 1.2. 1.2 says calculate the velocity with which the stone hits the water. So we need to calculate the final velocity. Because now given the initial velocity is 0, because this stone is going to start at rest. It's going to start its motion at rest and then build up that velocity to a certain value with which it's going to hit the water below the bridge. And also another important thing that I missed when I started answering this question, you need to draw your free body diagrams when dealing with such motions. Draw your free body diagrams because it will help you see or be able to visualize how this object is moving. So let me just draw a stone here, going down from the bridge. So this is the bridge there at the top. I hope you guys can see this. So we've got the bridge there. We've got the bridge and then there's water below the bridge. So this stone is moving from the bridge, or it's falling from the bridge towards the water there at the bottom. So you can see that the only force that's acting on the stone is the force due to gravity, because we're ignoring air resistance. They said we should ignore air resistance. So now let's move on to this one, second part. The initial velocity is 0 meters per second and the acceleration is still the same, 9.8 meters per second squared. Also in the same direction, downwards. So it's going to be positive since we chose our downward motion to be positive. And now, and now we're also given the change in time, or the time it takes to hit the water. So that's 6 seconds. So we're given this information. We need to find the final velocity. So you need to go back to look at your formula sheets. Go there, check which formula is the most suitable for this question. So now the one that's suitable is the one which says VF equals to VI plus A change in time. This is the most suitable formula that can be used to solve this second part of the question. So since we want final velocity, it's going to be 0, that's our initial velocity, plus the 9.8, which is the acceleration due to gravity, multiplied by the time it takes to hit the water. And now the final velocity, let's just use the calculator to get the value there for our final velocity. That's 9.8 multiplied by 6. And now we're going to get 58.8 meters per second. So you need to be careful when you're writing such quantities. You need to put in your SI units, because if you don't put your SI units, you get penalized for that. And also, since it's a vector quantity, you need to put in your direction. So this velocity is going downwards. So it's 58.8 meters per second downwards. So you need to put in your direction there, since this rock or this stone is falling from the bridge towards the water below the bridge. Now let's move on to the second question. That's question 2. Question 2 says, a bullet is fired vertically upwards from the ground level with a velocity of 28 meters per second. And also they're saying ignore air resistance, so ignoring the effect of air resistance. And now the first part says calculate the maximum height reached by this bullet. So now let's start off by drawing our sort of free body diagram, illustrating how this bullet is going to move upwards vertically. So now it's going to be going up like that. Now we're given the initial velocity, VI for this bullet is 28 meters per second. And also we need to check, or we need to choose our directions for this second question. For this second question, let's take upwards to be positive. So anything moving upwards is going to be positive. Any motion in the upwards direction will be taken to be positive. And then any motion that's going to be downwards, let's take it to be negative for this particular question. So that means now our initial velocity, since it's going upwards, it's going to be 28 or plus 28 meters per second. It's going upwards. So you need to remember that. Direction is very important when you're dealing with such questions. So you need to be careful when it comes to that. When it comes to choosing your directions and also being consistent in applying the directions that you've chosen. Okay, so now if it's going upwards, it's going to go to a point where it's going to reach its maximum its maximum height. That's where the velocity is going to be 0. At maximum height, your velocity is 0. You need to remember that. That's something that you need to remember and be very careful of when you're tackling such problems or problems involving vertical projectile. All right, okay. Now I've outlined that. Let's just write down what's given properly here. Let me just write it down here. Given information, we're given the initial velocity, which is plus 28 meters per second. That's upwards. And now we know that at maximum velocity of at maximum height, our velocity is 0 meters per second. Meters per second. So you need to be very careful of this, guys. When you get to a maximum height, the velocity is going to be 0 there. Let me just put in maximum height here in brackets. So you need to remember this. Okay, and now from there, let's just, okay, what's given again? Yeah, let's start taking the question now. 2.1, you understand? So now for this particular question, we need to use or to find a suitable equation from our formula sheet that can be used for this particular problem. So now we also given, we know the acceleration, which is 9.8 meters per second squared. So you need to remember this also. And since we're saying anything that's going downwards, it's going to be negative, and downward motion is negative because we're taking upwards direction as our positive. So now let's use the equation that says Vf squared equals to Vi squared plus 2a change in y. You understand? So now in this case, because we're looking for the maximum height reached, so let's just make this subject of the formula. So it's going to be change in y equals to Vf squared minus Vi squared divided by 2a. So now let's just plug in our given variables there, our given values. So the final velocity is 0 at maximum height squared minus initial velocity, which is 28 meters per second, divided by 2 minus 9.8 meters per second. So yeah, we're putting the negative there because gravity or acceleration due to gravity is always downwards. So in this case, we're saying downwards motion will be taken to be negative. That's why we're going to put our acceleration as a negative there. Change in y equals to, and then let's just plug in and then solve that particular equation. Minus into 28 squared divided by 2 into minus 9.8 meters per second. So this will be our height, or the maximum height reached by this particular bullet. So this is going to be 40 meters above the ground. So now this is a solution to the first part of our equation, where we are required to calculate the maximum height reached by the bullet. So that's 40 meters above the ground. So now it's very important for you guys to include such information when you're dealing with such problems. You understand? You need to show your examiner that you know what you're talking about. So give them complete solutions. You understand? So now let's move on to the second part of this same question. So now that's 2.2. We're moving on to 2.2. So now it says calculate the time to reach the maximum height. So the time that bullet is going to take to reach the maximum height. So we need to calculate that. So now we're still using the same given information. We just need to go to our formula sheet and select the suitable formula for this second part of the equation. So we're just going to use the formula which says Vf equals to Vi plus a change in time. And also remember that we chose upward motion to be positive and downward motion to be negative. So anything going upwards will be taken as positive and anything going downwards will be taken as negative. So this means that our acceleration due to gravity, that's still a negative, minus 9.8 meters per second squared, because it's always directed in a downward direction. So now from there, we just need to plug in. Before we plug in, let's just make the change in time subject of the formula. So we're going to be having change in time equals to final velocity minus initial velocity divided by acceleration. So now our final velocity at maximum height, that's 0 meters per second. So you need to remember that 0 minus initial velocity, which is 28 meters per second, divided by the acceleration due to gravity, which is given as 9.8 meters per second. And it's a negative in this case because downward is a negative direction. So now you just need to put in your calculator and it's going to give you an answer for your time taken to reach the maximum height. So that's 2.86 seconds. Remember, SI units are very important because you can lose marks for missing out your SI units. So now we're done with the second question. Let's move on to the third and last question. Let me just read it out for you guys. It says a ball is thrown vertically upwards and returns to the thrower's hand 7 seconds later. So we're throwing a ball upwards and this ball is going to return to the thrower's hand 7 seconds later. Okay, let me just draw a free body diagram to just show you or help you visualize how this motion is gonna look like. So it's going up there to maximum height and then it's gonna go back to the thrower's hand. This is the ball. You understand? So at maximum height, the velocity will be 0. So you need to put in your velocity there as 0 meters per second. Maximum height, maximum h. You understand? And also, we need to write the given information. So now we're given that it takes 7 seconds to return to the thrower's hand. So the change in time, or the total time, let me just say total t, that's 7 seconds. So that means from this total time, we can calculate the time that it takes to reach the maximum height and also the time that it's going to take from the maximum height back to the thrower's hand. So now let's just call it T1. T1 will be the time it takes from the thrower's hand to the maximum height. So assuming that this motion, there is no air resistance, there's only gravity acting on this ball, let's divide the time it takes, or the time it takes from the thrower's hand back to the thrower's hand as the total time. So we're just going to divide that by 2 to get the time that it's going to take to reach the maximum height and also the time that it's going to take to reach the thrower's hand, or to go back to the thrower's hand. So T1, this is the time to reach the maximum height, and then T2 will be the time it's going to take to reach or to go back to the thrower's hand. These two terms are equal, you understand? So assuming that it's going to take the same time to reach the maximum height as it's going to take the time from the maximum height back to the thrower's hand. So we have T1 and T2, those times are equal. So now, and also we need to write our acceleration, which is 9.8 meters per second. You understand? We also need to choose our directions now, which direction we're going to take as positive and which one will be taken as negative. So now let's take our upward motion to be positive. So anything going up will be positive. Let me just write it down here. Anything going up will be positive and anything going down will be negative. So that means now our acceleration due to gravity will be negative since it's always directed in a downward direction. So that's minus 9.8 meters per second. You understand? And now from there, all right, let's just go to our formula sheet and choose the most suitable formula for this first part of our question, which says calculate the maximum or the velocity with which the ball left the thrower's hand. So we calculate the velocity with which the ball is going to leave our thrower's hand. So that's the initial velocity. You understand? So for 3.1, we're calculating the initial velocity. So we're going to use a formula which says VF equals to VI plus a change in time. So that's what we're going to use for this first part of the equation. Let's just make a VI subject of the formula. VI equals to VF minus a change in time. And now from there, just need to substitute our given values. So now the final velocity, let's take the velocity at maximum height. So that will be 0. And then the acceleration will be minus 9.8 meters per second squared because it's always in a downwards direction. Multiplied by the time it's going to take to reach the maximum height. So remember that we're given the total time. So the time it's going to take to reach the maximum height is just going to be half of that total time. So it's going to be 7 divided by 2, which is 3.5. And now it's going to be 3.5. That's the time it's going to take to reach the maximum height. And then we're just going to put it there. So now we're going to get something like minus into minus 9.8 multiplied by 3.5. And that will be our initial velocity. So that's 34.3 meters per second. So this is our initial velocity. And remember, since it's a positive value, it shows that this velocity is directed in an upward direction. So it's going upwards. So it will be 34.3 meters per second upwards. You understand? So you need to be consistent with your directions, you need to be very careful when it comes to that, because you putting a different or a wrong sign, it's gonna jeopardize your entire solution. So you need to be very careful when it comes to that. Okay, now the second part of the question, which says calculate the maximum height reached by the ball. So we need to calculate the maximum height that this ball is gonna reach from the thrower's end. All right, let's go back now to our formula sheet to select the most suitable formula for this question. All right, the most formula, which is gonna be the most suitable one, will be the one that says change in y equals to v1 plus v2, that's initial velocity plus final velocity, divided by 2, multiplied by the change in time. That's what we're gonna use, okay? Or maybe, okay, yeah, let's use that one. It's the most suitable one. So now it's gonna say change in y equals to, we're still using the same initial velocity, which is 34.3 meters per second, the one that you just calculated in the previous question, or the previous part of the question. So that's gonna be 34.3 plus final velocity. Remember, at maximum height, our final velocity or velocity is 0 there. So we're just gonna put 0 there, divided by 2, multiplied by the change in time. So the time that's gonna take from the thrower's end to the maximum height, that's 3.5 seconds, right? So now we're gonna just need to use our calculator to just put that, plug that in and get an answer with it. Multiply by 3.5. All right, we're gonna get 60.03 meters. This is above the ground, above the ground. You understand? So you need to put in this details when you're solving such questions to ensure that your solutions are complete. You understand? You know what you're dealing with. And then the last part of this question says calculate the velocity with which the ball returns to the thrower's hand. So we need to calculate the final velocity, or the velocity with which this ball is going to return to the thrower's hand. So another thing again, we need to go to our formula sheet again. I know it's tiring sometimes, but you need to always refer to your formula sheet, because you can't always remember all these formulas. You understand? You can't afford to make mistakes of writing incorrect formulas and stuff like that. So let's go to a formula sheet. The suitable formula that we can use says VF equals to initial velocity plus a change in time. All right, okay. So now in this case, we want the final velocity. And now we're taking the motion from the maximum height back to the thrower's end. That's the motion that we're dealing with. So we're dealing with the motion from this height here, the maximum height, back to the thrower's end. So we're dealing with this section here. You understand? And we're looking for the final velocity. So that's the velocity here. That's what we're looking for. And now, since we know that the initial velocity or the velocity at maximum height is 0, so we're going to put 0 there. And then the acceleration is minus 9.8, since downward motion is negative. 9.8 multiplied by the change in time. So that's the time that's going to take from the maximum height back to the thrower's end. So that's 3.5 seconds. You understand? That means now our final velocity, it will be minus 9.8 multiplied by 3.5. So that's minus 34.3 meters per second. So this negative sign here just shows that this motion is in a downward direction, since we chose our upward motion to be positive. So we need to put in the direction as well, since we're dealing with a vector quantity. Meters per second, downwards. You understand? So that's the final velocity, or the velocity with which the ball hits or goes back to the thrower's hand. And yeah, that's it for this lesson. Thank you guys for joining me, and also please do join us in the next lessons. And also don't forget to subscribe to the YouTube channel